So talking about expected value. What we want to do is talk about how can we use probability to make a decision. So we want using probability to make a decision about something. We want to know in the long run what is going to happen. And that's what expected value that's what it really tells us. Expected values it tells us what is going to happen in the long run. So the way you usually see expected value is if you're playing some kind of game and you have some chance of winning something and some chance of losing something. You want to say, is it worth using this strategy? Is it worth paying for this ticket that I might win some prize? Is it worth it? What's going to happen in the long run if I do this? And so expected value helps us, like I said, make decisions. Expected value is really easy to find. So to calculate, we multiply. And the two things we multiply are the probability times the value. If we have more than one event, we calculate the expected value for each one and add. So if we have several things that are going to happen, we just add the different expected values together. And that's all there is to expected value. So all I want to do with this is just do a couple of examples of working with expected value. So to calculate, we're just multiplying the probability times the value. If we have more than one, we do that for each probability and each value and add all of them together. So let's look at an example. So let's say we are buying a game ticket. So you go to some kind of thing and they have a raffle. You can buy a ticket and you know that you have a 70% chance to win $1. You have a 25% chance to win $5 and a 5% chance to win $50. So the first question is, what is the expected value of this ticket? So to find our expected value, we just need to multiply the probability times each value and add them all together. So I'm going to write EV for expected value. I'm going to have to write it that entire word. So the probability of winning $1 is 70%. How are we going to write that to multiply? What do we do? turn it into a decimal. And how do we turn 78% into a decimal? Two to the left, go the opposite direction. So it's going to be 0.7 times the value, $1, plus the next probability and the next value, 0.25. We want that. I already gave it away. 25% is a decimal, 0.25 times $5. That's the value of that probability. And be careful with this one, 5% as a decimal, 0.05. If we had written 0.5, what would that probability be? 50%. So 0.05 for 5% times 50, and 0.7 times 1, so we get 7 plus 1.25 plus 0.05 times 50 is 250. Add those together and we get $4.45. So in the long run, what you would expect is that ticket is worth about $4.45. Sometimes you might win, sometimes you might lose, but in the long run, you'd end up getting about $4.45 for a ticket. So if this game costs $5, would this be a good game?
No.
No, because you'd, in the long run, for each ticket, you'd lose 35 cents. You're spending $5 and you're only getting $4.45 back in the long run. So for a $5 game, this probably wouldn't be a great game. It would be terrible, and usually these games are meant to raise money for whatever the program is, so the game is supposed to earn money. For $4, that's a little better. That'd be a little better game. You'd stand to make a little money in the long run. So that's how we can use this to make decisions. You say, oh, do I want to spend $5 on that ticket if its value is only $4.45? Probably not. Questions on how we calculated that? All right. Let's look at another one. And this one, we'll just add just a little twist here. We are making an investment. And our broker says, our investment broker says, we have 30% chance at $4,000. So we're going to earn $4,000. We have a 60% chance to lose $1,500. And a 10% chance to earn $1,000. And the question here is, would you recommend this? So what we need to do to make a decision here is find the expected value. Find, I'm going to say EV. Find the expected value so we can make a decision. So let's calculate our expected value. 30% chance of $4,000. So I'm going to write my expected value is 30 as a decimal, so 0.3 times 4,000. This says we have 60% chance of losing 1,500. So what do you think I'm going to do with that expected value? Subtract. We're losing. It's taking away from our value. So because we're going to lose $1,500, we're going to subtract that 0.6 times 1,500. This tells us we are going to lose money. So when we have a chance of losing, we subtract. And then we can earn 10% chance, 0.1 times 1,000. When I calculate this out, 0.3 times 4,000, 1,200 minus 900 plus 100. So my expected value is $400. So in the long run, we would expect to earn, for this investment where we have these chances of earning and losing money, we would expect to earn $400 on our investment. Is that a good investment? It could be. I mean, you're not losing money. You're expecting to earn money. You're not earning a lot of money, though. It would depend on how much you put in. So if you were investing $10,000, you kind of hope to earn more than $400. But if you were investing $2,000 and you stood to earn $4,000, that's not terrible. 400 is a decent proportion of $2,000. So you could use this to make a choice. So the recommend part, there's not really a right and wrong answer, unless I wouldn't recommend it, definitely wouldn't recommend it if it was negative. If the expected value was 0 or negative 20, something like that, you'd expect to lose money. But to make decisions, we find the expected value using our probabilities. And anytime we're losing something, the expected value is negative. So if you're playing a game and you have so many percent chance of moving forward and so many percent chance of moving backwards, the expected value of that backwards move is going to be negative, to figure out what the expected value of your move is. If you're losing points, the expected value of that whatever it is that loses points is going to be negative because you're taking away from your value. All right, questions there? Okay, that's all there is to expected value. All right, homework. What's that? So the assignments 10 through 16, number 18 is extra credit. It needs to be correct with all work to get credit for that.